All right, 6.6.30. This one has a little bit of a trick in it at one point that some books will explain just as a property to remember or memorize or use at all times. I'll show you the why it works. But you've got this 2, and then if you want to use it just as a rule or a property in the future, put it in your notes, and you may, but it goes, so the original problem, 2 times the natural log of the 4x minus 1 equals the natural log of 23x plus 3. To work this problem, first of all, again, we're supposed to remember that when you have a coefficient out here, you can put it up here in the exponent. So it really is the same as the natural log of the 4x minus 1 squared equal to the natural log of the 23x plus 3. And then some places will explain it at this point as, well, if you've got a natural log of one thing and it equals the natural log of another thing, doesn't it make sense that those two things just have to equal? And that might be the easier way to approach this. And then we just solve this quadratic. So 4x minus 1 times 4x minus 1. Yeah, I'm just going to leave that right side alone rather than copying it down. It just uses up time. Do it more efficiently. So remember your 4x times your 4x, you'd have a 16x squared. Your minus 1 times your minus 1, you'd have a plus 1. And then don't forget in the middle, you've got a negative 4x here and a negative 4x here for a negative 8x there. Okay, and then you've got 23x plus 3. Subtract your 23x over, that's negative 31x then, and subtract your 3 over, and you've got a negative 2. So I think I'm starting to see this, because 16 times 2 would be 32, and then a 1 would make my 31. So for my factoring on that, I do think, it seems like not very often do they use a big number like that where you do the number in just 1. But in this case, I'm going to want that times the 2 to get my 32x, and then 2 times 1, because that's a 2 there, is just my 1. And so 32x and 1x, I can get a 31x in the middle. Again, I want the 31 negative, so this 32 needs to be negative. That means a negative out here. So 2 times 16 negative and a plus there to make that. That's going to give me my negative 31x equal to the 0. And then set your factors equal to 0 and solve. So my 16x plus 1, when does that equal 0? And my x minus 2, when does that equal 0? So you get a 2 from there. And then this one, subtract 1 and then divide by this 16. And so sometimes you can't have a negative inside your log. So inside of a log expression here, it's always going to be positive. So I'm kind of wondering if I put that negative 16 in either of these, is it a valid solution? So inside of a log, because your base is always positive, you can never do an base to a power and get a negative number in here. So I'm going to check that. If I put the negative 1/16 in either of these places, if I get a negative, I can't do that. And I would have to right here, because 4 times a negative is a negative minus a number. So then this negative 1/16 is not a valid solution. So my only one is the 2. So it says there is no solution that is not extraneous. So that would be like, so the solution that is or are extraneous. So there, the 2, I believe, should work. If we tried this, you could do a 2 natural log to check your work, 4 times 2 minus 1, and see if that equals the natural log of the 23 times 2 plus 3, and I think those two sides will check to equal from what we just did down below, but I'm just going to do it on my calculator quick and just see. 4 times 2 is 8 minus 1 is 7, and that gave me like 3.89, and then let's see, the natural log of 23 times 2 is 46 plus 3 is 40. 46 plus 3 would be 49. And that's the same. So yeah, the 2 is my solution. The solution that is not extraneous would be the 2. That's the one that worked. And the solution that is extraneous was the negative 1/16 right there. So I never did show you the one little trick. That's the solution to the problem. If you wanted to see the one little trick that I was going to tell you, that a lot of books will show as a property or a rule, it would be, I'm going to go back and get rid of all this. And here's what they do. They say if you have your base e to a natural log or a log base e of an expression, then this really just equals whatever that expression is. And it kind of goes a little bit like this. We'll break it down a little bit simpler even. If I have an e to a natural log of something, well, what does that mean? Equals x. And so remember, log base e right here of the x is how you convert, equals my natural log of that equals the whole exponent. And then remember, log base e is just natural log. So natural log of x equals natural log of what? And doesn't it make sense that then that would just have to be that exponent? So anyway, back, if you ever get one that has a e to a power of e log base e or e to the power of log base n, or if you had 10 to the power of log base 10, it's always just going to equal this thing, and they'll just give that to as like a property or rule that you can always use. All right, that's 6.6.30.